Hey, welcome to NASA Edge.
An inside and outside look
at all things NASA.
Oh, that's gonna leave a mark.
Welcome to NASA Edge.
An inside and outside look
At all things NASA.
Great to have you in the studio there, Franklin.
Yeah, I'm glad to be back in the studio after all this time out in the field. It's so hot out there, I didn't want to take my hat off.
Well, it's nice to be in climate control.
Well,
Yes.
plus he's about to have twins.
Oh, that's true.
Yeah.
Yeah.
Which means you'll be living in the studio.
We'll see in a couple months after that happens, from my experience last year.
Yeah. But having twins is kind of like working with you guys.
Okay, on today's show, we're going to be focusing on technology.
Yeah, technology.
Which is a really good show, and we have a treat because at the end of the show,
Yes.
we're going to have Bobby Braun, who's the director for the Office of Chief Technologist at NASA headquarters.
Yeah, but before we talk too much about technology, if we're going to have a decent timeline on some of these breakthroughs, we need partnerships.
In fact, we actually went down to NASA Johnson Space Center to talk to the Robotics division, and they have a pretty cool partnership with Caterpillar.
And that's a cool partnership, unlike some of the less successful partnerships like Cyberdyne and Strategic Air Command and NORAD. That was a bad partnership. We don't want that. We want good partnerships.
So let's check out the segment with Caterpillar.
So the multi-terrain loader is a piece of equipment that's used in the construction industry. Its purpose is a highly versatile machine. So with this coupler here, you can attach to a wide variety of tools. So the large number of applications that's required in the construction industry can be accomplished with the platform. It's one of the smaller machines that we have and more comparable with some of the machines that NASA is using, and it's all electronically controlled, which sets the stage for it to be able to be fully automated. Some of the sensors you can see here, like the 2 GPS units up top,
Right.
the cameras across the front here, and the cylinders are instrumented so we know their extension or their length at any given time, and then we can kind of determine where the tool is relative to the machine.
You can tell Caterpillar is really cool, but NASA does some cool stuff. So what are we actually gaining from this relationship?
One of the things that we could benefit from is knowing how to minimize the amount of energy we need to expend for construction tasks. For a planetary mission, if we were going to the moon or we were going to Mars, or even perhaps on an asteroid, using technology that Caterpillar has already developed, we could minimize the amount of energy needed to perform a certain task.
So Eric, what's Caterpillar hope to get from this NASA-Caterpillar partnership?
Well, it's the development of some of those key technologies that's needed to be able to remotely control these machines and to make them more autonomous so that we can remove the man from the machine when it's operating in hazardous environments, in environments where it's very remote and very harsh, that we can more centrally locate some of those operators so they don't have to be out in those environments and conditions.
The partnership was first conceived in 2006. We formally began in 2007. And since then, we've accomplished remote control with the machine. We built a control station for the MTL. We've controlled machines between Illinois and Texas over the internet. There are also other things going on with our partnership with Caterpillar, such as perception tasks that could be useful on a variety of different platforms, including in space.
Now, what's an example of a perception task?
Well, say you wanted to determine the orientation of an object floating in space. You could do that using depth mapping technology that NASA has been working on and Caterpillar has also been working on. But Caterpillar has been working on detecting a lot of different objects in their construction environment, other machines, people. The other thing is that robotics as an industry is developing fairly rapidly right now. Caterpillar has money and energy to investigate different technology than NASA would choose. So although we have parallel efforts as far as perception is concerned, they might have tested one sensor that we haven't tested, and we can instantly gain knowledge of some technology that's already out there.
So Eric, tell me about the education and public outreach aspect of Caterpillar.
Specifically with robotics and automation, we're heavily involved with FIRST Robotics, as NASA is as well. And we sponsor teams not only in the US, but around the world. And also we are involved in the Lunobotics mining competition at Kennedy Space Center. We're very excited about that as well, and the fact that that's growing and becoming international as well, because Caterpillar is a global company. Many of the international teams are coming from locations where we're expanding and we need to recruit from, like India. We view that very positively and we're very excited about that.
Speaking of sharing, is there any opportunity for me to maybe pick up one of these in excess? Like when you're done with the partnership, the co-host, NASA Edge, could just take over an MTL for our own partnership opportunities in the future.
I think we've got a waiting list already, but we can put you on it.
Well, you heard it here first. NASA Edge is on the list.
Before we go, I have one question. Can we give Spooner a ride in the MTL?
Sure. Yeah.
Let's see what happens. Cool. Yeah, that multi-terrain loader is pretty cool.
Hey, how did it handle?
Handled pretty well. Like I said, I almost tipped it over, but recovered very well and actually had a chance to drive it for a few minutes.
E-Stop, very effective piece of technology. That's
Oh,
just
you better
kind of
believe
a
it.
sidebar of the whole Caterpillar NASA partnership.
I mean, I didn't realize it worked on you too.
Yeah,
So,
well, I've rebooted. I'm feeling pretty good.
so we're doing this promo for Caterpillar with the E-Stop. He says, "Okay, I've got the fall that I'm going to do, but I'm not going to show it to you until we actually shoot."
And it's the reason I didn't want to reveal the fall is because I didn't want to have to do it a lot. So I had it all in mentally. I had it in mind.
So anyway, he comes on in.
Action, rehearsal.
Everybody's at lunch. Time for a little experimental joyride.
What are you talking about?
Turn and burn.
And he does like a, it seemed like it was a 360. His legs go flying through the camera and hits the ground pretty hard. And everyone just starts busting out laughing. And I'm looking at him like, is that the fall? I mean, that was it? Is that it?
No, that wasn't it.
Are you?
Yeah, he was disappointed. I'm sitting there checking my pulse and all my vitals, and he's wondering if that's the fall.
Please tell me you got that on film. But I have to give you credit. I mean, you did a pretty good job on the promo.
Yeah, I have a whole new set of stretching exercises I have to do every day, but apart from that.
Let's go ahead and take a break.
Hey, when we get back, we're going to talk a little bit about space brakes.
You're watching NASA Edge.
Inside, outside, look at all things next.
Did you say space brakes?
Space brakes.
Space brakes.
Hey guys, I recently had an opportunity to talk to the researchers and engineers over at HIAD, which stands for the Hypersonic Inflatable Aerodynamic Decelerator, or what I like to call space brakes. It's very interesting technology. It's something that I would have never thought of, having an inflatable structure in space to slow down spacecraft.
Inflatable structures, in the general sense, is becoming very popular.
Yeah, but I understand it a little more in the HAB because we do have decelerators now. We use parachutes. How does this? Are we still using parachutes? Is this a different thing altogether?
Well, we're using inflatable structures in addition to parachutes because what happens is that the size of the spacecraft can only get so big, and after it gets larger, you need a decelerator that's going to go ahead and slow it down.
So with the inflatables, that structure can go beyond the spacecraft and then slow it down.
And I'm just assuming, I'm sure we'll find out in the story that the inflatables weigh less than, like
that's
your
the big
normal,
thing.
That's
the big difference.
Now, are they partnering with those inflatable moonwalk things that kids use as part of a technology partnership, or is that separate?
Are you talking about moon bounces?
Yeah, moon bounces, yeah.
No, I doubt it.
I tell you what, let's go check out the segment on HIAD.
Just checking.
I'm here with Neil Cheatwood, Principal Investigator for HIAD. Exactly what is HIAD?
Well, HIAD stands for Hypersonic Inflatable Aerodynamic Decelerator. And let me break that down for you. When we go to other worlds, we have to launch from Earth, and then we have to decelerate. And we can do that either propulsively, like we did at the moon with the lunar module, and use just engines to slow us down. But if it's a world with an atmosphere, then it makes sense to make use of that atmosphere and the atmospheric drag. And so what we do is we actually wrap our payload, what we're taking to the surface of the planet, we wrap that in what we call an aeroshell. We're currently limited to the size of aeroshell that we can do based on the rocket size. So our aeroshell has to fit inside that rocket shroud. And so the idea is if we could deploy a larger aeroshell out of a given rocket, then we could take down more mass and actually get more payload to the surface of Mars or Venus or wherever. What we're working on here is a hypersonic version of that where we deploy outside the atmosphere, but then we have to handle that heat pulse, the high deceleration pulse that we see when we go into the atmosphere. So that is a hypersonic inflatable aerodynamic decelerator.
One of the big parts of HIAD is the inflatable structure. So tell us a little bit about how it is constructed.
Okay, well, what we have here is a stacked torus, and the way you make a torus is you braid a tube, and then that tube then has a liner, a silicone liner inside of it, and you inflate the tube, and it becomes a torus. And if you stack the tori together so they intersect or interfere with each other, they become a pretty rigid structure, which you can see over here. We have to protect the structure from the heat of reentry, so we apply a thermal protection blanket. The outside is a Nextel fabric, which we've quilted together. And I'll take this ring off and show you the way it's constructed. The fabric itself keeps the integrity of the outer structure. Then we have an insulator ply, which you can see is this powdery yellow surface in here. That takes the outer surface heat and knocks it down to a temperature that the bladder can tolerate. And we have these gas barriers beneath it that prevents inflow of the hot gases. The hot gases on the outside are wanting to drive to the low pressure. Behind her in the wake region of the aeroshell is a very low pressure. So the pressure on the front wants to drive through, so we have to put a gas barrier behind it. And this is a test sample for running in the 8-foot high temperature tunnel. We've instrumented it with some thermocouples so we can see what the various temperatures are in between the layers, and we can match that up to the models that we've done for prediction to see how well the TPS performs.
Should we explain a little bit more about why you would use an inflatable reentry system versus the old rigid thermal heat shield?
We've been to Mars, as an example. The first time we went was in 1976 with Project Viking, and there was a big technology development program for Project Viking. They developed a TPS material called SLA 561V, which is super lightweight ablator, 561V for Viking. We've actually used that on every successful Mars mission since then, and here we are in 2011. And so we've been using all that technology all these years, but we've been sending more and more stuff each time. So the payloads are getting bigger. In actuality, our next mission to Mars is the biggest payload we've sent there, the Mars Science Laboratory, and we had to switch our TPS materials because it was getting so heavy. And even with that, we can only land at what was below sea level at Mars because we're just coming in too fast, we're too heavy. So the idea is to make a larger drag device so that we could land that same mass at a higher altitude or take more mass to the surface. So it's all about size. Size does matter.
Your next test coming up is IRV-3. Tell me about that.
IRV-3 is another suborbital flight. We've had IRV-2, which is our first successful demonstrator. IRV-3, we've increased the mass of the payload so that we can get about twice the heating applied to the aeroshell. And this time we're going to require a TPS. The last time we just had the fabric to show how well it's stowed and whether it would survive the rigors of packing. This time we need to demonstrate that we can pack with the insulator. And the insulator is a fairly low density material, so we need to make sure that we can pack it down very tightly. And it's also a fairly delicate material, so we need to make sure that it doesn't fall apart when we package it and then later deploy it.
Neil, tell me about where we might be able to use this technology.
We can use the aeroshells where we have a sensible atmosphere. And when I say sensible atmosphere, it has to be enough that really means anything. The moon does not have a sensible atmosphere. That's why we landed using retropropulsion. Mars has what I call a poor excuse of an atmosphere. It's very thin. It's the most challenging destination for us because it's actually too thick an atmosphere to ignore. We don't want to just take rockets and land on the surface. It's not very efficient. But it's so thin, it's like 100,000 feet here at Earth. You know, it's very, very challenging. But we can use this technology at Mars. We could use it for Earth return. We could bring stuff back from space station. We could bring stuff back from the moon. We can use it at other atmospheres like Venus, the gas giants, Jupiter, Saturn, Uranus, Neptune. Titan, which is the large moon around Saturn, has a very thick atmosphere. So it could be used at any of those locations.
We've done some studies and demonstrated that these are enabling technologies for way out there where we're doing a manned Mars mission. They're talking about landing 40 metric tons of payload on Mars. Right now, there's absolutely no way to do that. Well, these aeroshells are potentially a technology that will allow us to do that once we figure out a way to get 40 metric tons to Mars orbit. So that's another challenge.
That's a big challenge.
It's a big challenge.
But you're up to the challenge.
Oh, yeah, we're on it.
Now you know why I call them space brakes.
I was wondering, do you think they'll come up with a anti-lock version of the space brakes?
Anti-lock space brakes. That's actually not a bad idea.
Yeah, well, I mean, it's all part of my partnership.
He's on the phone.
Oh.
Is it time?
Time for me to roll out.
Oh, it's time.
There you go.
Hey, have a good one.
Don't smoke the cigars till you get home.
Let us know. Twins are on the way.
Yeah.
You hear it first on NASA Edge. Twins are on the way.
An inside and outside look at all things deliverable here shortly.
But when we come back, we still have a show to do.
Oh, that's right. We still have a show.
And we have Bobby Braun in the studio. We see him down the hallway. He's going to be right here talking about the future of space technology.
And maybe Bobby Braun will hand him to Franklin some new technology on the way out the door.
Franklin, get out of here. Let's go.
Welcome back to NASA Edge.
An inside and outside look at all things NASA.
Hey, Bobby, thanks for joining us today.
Thanks for having me here.
Now, we're looking at space technology. The theme of this show is technology, but you're the guru of space technology.
Yeah, apparently, if there's technology happening at NASA, you're the guy to talk to.
Well, there's technology happening all over NASA. That's been the case since the formation of the agency. I'm just trying to emphasize it and to get it out into the open, share it with the public more.
And now that Shuttle's going to be retiring, what's the direction for space technology?
Well, since you mentioned the shuttle, let's talk a little bit about human spaceflight. NASA has a vibrant plan for human spaceflight. You've probably heard about our use of the space station. You've probably heard about how we're building some of the first building blocks of the deep space exploration capability with the heavy lift launch vehicle and the multi-purpose crew vehicle.
Right.
But when we send humans into deep space, they need many more things than just those two systems. We need to be able to move about efficiently in space. We need to be able